split operator. So we use split operator in a lot of use cases on a day-to-day basis, right? So let's say if you were to given a UTC timestamp or something and you need to get the date out of it, the first approach that comes to our mind is split operator. We split it in the middle and we get the date, we get the time, and a lot of similar things as such. Let's say you want to get the nth word of some sentence, then we would use split operator and as such, right? But one intuition that I want to build with this and the last few and the upcoming series of videos is mutations are mostly more performant and more efficient than initializations. Why I'm specifically discussing about split operator here is every time you use a split, it causes an initialization. So even if it is the intuitive solution, sometimes the most intuitive solution might not be the most efficient one, right? So let's take an example out of it. So let's see, let's say we have response sentence equals to, we have a word and then we repeat it for 1, 6, 20 power 6 and do plus 6, 9. Cool. So our objective here is to extract the last word for the whole sentence, and it's a very long sentence, right? So we are seeing space and we heard words. So the first approach that comes to our mind is using split. So let's try using split. So let's do sentence ar equals to, let's say, sentence dot split. We split it by spaces and const last word equals to sentence arr. We take the sentence arr dot length and we do -1 to get the last element and we do console.log. Let's say last word, and the last word is this, whatever we got a while back. Last word. Cool. Also, let's measure how much time does it take to perform this whole operation. So let's do const start equals to performance.now, and then we can do const end equals to performance.now. Cool. And let's calculate the time taken. So we do this, we do time taken, and we do and minus start. That's all, right? So it should print the last element, and it's pretty straightforward. It works. So yeah, it printed the last word, right? Last word of the sentence, and it took about 400 ms, about 800 ms, about 400, 478. Let's average on 600 or something, right? So takes about 600 ms with this approach, and this is the obvious go-to approach that comes to our mind whenever we hear anything related to separating a string for some element or any similar use case as such, right? But the problem here is, like I said, every time you use split, you need initialization. Every time you initialize, you need memory, and whenever there is initialization, let's just look if you can optimize that part. Like some initializations are necessary, right? But some you might get the same outcome without doing those. So let's try another approach. Let's do this. Let's do const length. No, sorry. Let's call it something relevant. Let's call last index or something, right? Let's call last index, and we do sentence dot length, and we do -1. So it's the last index of the sentence. So this will be this 9 if we log it out. And then we do while let's say sentence last index is not equal to space. It's not equal to space, and let's say just so that it doesn't go in infinite loop, we do last index greater than equal to 0, and then we do last index decrement by 1 for every step. So once we encounter a space, we exit the loop, and then we do this const last word equals to, let's say, sentence dot splice, and we do last index +1. Let's try this. Oops. Oh, sorry, it should be that. It's not splice, my bad. It's slice. See, we got the same outcome, and it took about 5 milliseconds, which is like, if you compare 600 with 5, that's like 12, 6, 4. On average, let's average it out at maybe 10 or 20 or something, right? So it takes a very, the point I'm trying to make is it takes significantly less amount of time, even if you average out at, even if you take an average time of 10 millisecond, it's like 60x faster, right? So that's the power of mutation, if you know when to use it and how to use it. We can also try doing this. Let's say we have last index. If we start at maybe, okay, that won't be a very optimized approach. I was trying to see if we can start from the beginning till the end and how long that takes. Let's try that actually. Let's say we have last index this, and we already made the point that we're trying to make, and then let's try this now. Let's say where first index equals to, let's say, 0, while index is less than equal to sentence.length, and so let's do const where space index, I mean the index where you encounter a space. It's not a very efficient approach, but I'm just trying to see if we do go by the least efficient approach, will it be efficient and creating an initialization or not for this particular use case. So we do space index, and then index, and index is less than this, and then let's say okay, it's the worst approach that we can go for the worst case scenario. So if we do this, if we do sentence and index is space, then we do space index equals to index, and then we do index plus plus. Cool. And for this we put space index plus 1, and let's try printing this. Let's see how long it takes. See, even if we went by the worst approach possible, like we traversed through the whole string from the start to the end, right? Here we are increasing the index by every single time we are doing anything, we are increasing the index. I should time this for the sake of it. Yeah, it works. So the point I'm trying to make is, even with the worst case scenario that you can have in this use case, you are traversing through the whole sentence from the start till the end until you encounter like for every space you are tracking the index. Even if you take the least efficient approach here, it's still a lot faster than creating an initialization, right? So that's how powerful mutations can be. Like, so whenever you see any scope to avoid any kind of unnecessary initialization, don't do it. Try to do it via some kind of mutation, or without initializing, without that operation that would like occupy memory while initializing it, right? So this takes a bit longer than the initial approach, but it's still a lot optimized than the one that you split, right? So it's maybe 6x, 7x faster. Cool. Yeah, that's the point I was trying to make. So whenever you see any scope in your code where intuitively you feel like using something that would initialize something, try to see if we can do it without that, or if we can do it by mutation. Cool. Yeah, that should be it for this video. I think we'll discuss about something new in the next video. If you have any questions, please feel free to comment, and if you have any suggestions, same. If this was helpful, maybe share it with your friends. And yeah, that should be it for this video. Bye. See ya.